here we are on page 7, and if you remember at the end of page 6, we talked about standard form, which is kind of a useless form. It just looks nice. It's got the equal 0 here. And then we also talked about point gradient form, which is, except for slope intercept form or gradient intercept form, point gradient form is also super useful. Okay? Number 1, find in point gradient form, which is this one, the equation of the straight line with gradient 3 and passing through a point 1, 4. And now you can see how useful it is, because basically all you need to do is fill in a few of the blanks, which are the slope and 1 point, and then you already have the equation written. So for this one you would put y, you don't fill in y and x, you just leave those, okay? Y minus 4, because the y coordinate of the point given is 4, and then the slope is, the gradient is 3, and then you put x minus, and then you put the x coordinate. And you're done. That's it. You just write y minus 4 equals 3, parentheses, x minus 1, parentheses, and you're done. That's what they wanted, the equation of a line, or in point gradient form. Okay, maybe later they're going to ask you to rearrange it, but this is like most of the points if you can get this done. Next, they said the gradient -5 and passing through 7 and -4. So again, you're just going to fill in these yellow fields. You're going to put y minus -4. It's kind of tricky because it's -4, so I need to put y minus -4. And then I'm going to put equals, and the gradient is -5, and then x minus 7, right? Oops. X minus 7. And maybe, if you want to simplify it a little bit, instead of putting minus -4, you could put y plus 4 equals -5 times x minus 7. Okay? So that's that one. Then it says, with gradient 1/2, and -1/2 and passing through -1, 3. So let's do that. So we'll put y minus 3, right, equals -1/2, parentheses, x minus -1. And remember, x minus -1 is x plus 1. Okay? Last one, passing through the 2 points -1, 4 and 1, 8. Okay. So for this one, it's kind of weird for them to say put this in point gradient form because they gave us 2 different points, right? But let's do this. Let's pick one of the points. We'll pick -1, 4, and we'll use that point, okay? And then we will find the slope between the two. How do we find the slope between 2 points? That's right. We use stat, calc, and reg. So we'll go stat, edit, and we'll put the 2 points -1, 4. Oops, let's go back and clear this. Let's go up here and clear this. And then we're going to put the 2 points -1 and 4, and then 1, 8. Okay, so we got these 2 points, and let's find the slope between the two. Stat, calc, lin, reg. And then we go down to calculate. And we got y equals 2x plus 6. And what's the slope? It's just 2, right? So we'll put y minus 4 equals the slope 2 times x minus -1. And x minus -1 would be x plus 1, right? So that's the equation for that one. All right. Number 2. And also, of course, y equals 2x plus 6 would also be the equation for this line, but that wouldn't necessarily be in point gradient form because we want to use one of the points in -1, 4 or 1, 8 as our point, right? Okay, number 2. Draw the graph of each of the following lines. Okay, and let's see. We got something in point gradient form, we got something in standard form, and we got something in gradient intercept form. let's start out with B, because that's the easiest one, okay? So with B, what we're going to do is we're just going to type it in the calculator. So, and then we're going to pick out some points on the table. So we'll put -2/5. I put it in parentheses, times x. It's safest to put fractions always inside parentheses, okay? Or if you use the vertical fraction, then you don't need to. And then I'm going to look at the table to get a few points, okay? Now, some people might think, oh, I'm just going to graph it, and then I'm going to copy the graph to the grid. But it's really hard to do that because this grid doesn't have grid marks on it. So it's easier if you just go to the table, and then you're going to choose a couple points like 0, 4, and 5, 2, which are nice round points. 0, 4, and 5, 2. And then that makes it really easy to use a ruler and draw the line perfectly, right? So that was B, okay? So we did this one. We did it in red. And then let's do part A in green, okay? Now, in order to get points that the points that go through that this line goes through, it's easy to get one of the points, which would be this and this, right? Just be careful that x plus 2 is actually x minus -2. So the 2 points would be -2, 1. And it's also tricky that this one on the right side is the x coordinate. It's paired with the x, and this is paired with the y, so that's why this is the x coordinate, this is the y coordinate. So -2, 1 is one of the possible points. -2, 1. It's that right there, right? Okay. But how do you get another point? Okay. You can get all the points by graphing this in the calculator. Now the problem is when you want to graph in the calculator, it wants to be in the form y equals something. And this has y minus 1 equals something. So if we move the -1 to the other side, then we have y equals something. So let's do that. We're going to add 1 to both sides. So the right side is just going to be this, like it was originally, and we're going to add 1 to it, and that is what we can put in the calculator. Okay, and you're like, oh, well, I could have distributed -0.5. Yeah, you could, but it's not necessary to get the calculator points. You don't need to simplify it. So I type that in the calculator, and then I'm going to do second table, and it's going to give me some of the points. So one of the points, of course, is going to be -2, 1. If I scroll up a little bit, there's -2, 1, which I already graphed. And look, it also goes through 0, 0. Okay, so now we have 2 points, and that's enough to draw our line. Okay, so there's our green line. And finally, we're going to do part C. And part C is almost in standard form. If 1/2 was on the left side, it would be in standard form. It's not really in any form. It's not in gradient intercept form because y needs to be by itself for that form. It is not in standard form because everything needs to be on the left side and 0 needs to be on the right side for that form. And it is also not in point gradient form. So, but to put it into slope-intercept form with the y equals on the left side by itself, which is the most convenient to graph in the calculator, not too hard, right? We just subtract -2x from both sides, and that gives us y equals -2x plus 1/2, right? If we subtract 2x from this side, we just get y. If we subtract 2x from this side, we get -2x plus 1/2. So now it's in gradient intercept form. Now we could put it in the calculator and find out all the points we want. So we put -2x plus 1/2. 0.5 is a little bit easier to type in the calculator than 1/2. And then I look at the table. And if I look at the table, I can have all the points I want. None of the points are really nice. Everything's like 0.5, but one of the points would be 0.5. And another point would be, for example, 1, 1.5. So 1, 1.5 would be there. And so on. So there's our line. Okay, so there's our blue line. And we're done with number 2. Okay? Always draw lines with a ruler if you're doing a serious assignment or if you're doing a test. Okay? Number 4, determine without graphing whether -4, 5 lies on the lines with equations negative x minus 9, and 5x plus 4y equals 9. Okay, so there's two ways to do this, and one of the ways is you can simply plug in this x and y value into each one and see and test it to see if you get equal values on both sides. So let's try that, and then we'll look at it with the calculator. Okay, so we have we're going to put negative 4 in for x, and we're going to put negative 5 in for y. Let's see if that works. Negative 5 equals minus negative 4, so that would be positive 4 minus 9. Negative 5 equals 4 minus 9. Yes, it is. So yes. Okay, and what about for 5x plus 4y equals 9? 5x plus 4y equals 9. And let's put negative 4 in for x, and let's put negative 5 in for y. So that would be 5 times negative 4 is negative 20. 4 times negative 5 is negative 20. Does negative 20 minus 20 equal to 9? No. No. Okay, so negative 4 and negative 5 are not on those lines. How could you do it with the calculator? Well, this one's pretty easy because it already has y equals on the left side. So all we need to do is put in negative x minus 9 in the calculator and look at the table. And we can look at the table and we can see that negative 4, negative 5 is one of the points, right? So that, yes, it is. Okay. And then for the other one, 5x plus 4y equals 9. Now, this is not quite calculator ready, right? So one thing we could do is we could rearrange it with y equals by itself on one side. So we can subtract 5x from both sides. So we'll get 4y equals minus 5x plus 9. And then we divide both sides by 4. So we get y equals negative 5x plus 9 divided by 4. And then if we graph this, we can see if negative 4 and negative 5 is on the line, right? So I'm going to make a fraction, and the top of the fraction is negative 5x plus 9, and the bottom of the fraction is 4. And then I'm going to look at that table, and then I'll check out, okay, the value for negative 4 is 7.25. So no, it's not, right? Last problem, number 5. Frances runs along a straight line with the equation y equals 1/2 x plus 4. She starts at point C and finishes at point D. Find the y coordinate of point C if x equals 6. Find the x coordinate of point D if y equals 9. Okay, so like I said, whenever you get a problem and they give you a function in this class, go right to the calculator and graph it, because it's probably going to help you answer all the questions they ask you. So 1/2 x plus 4, notice I put the fraction in parentheses, which is always a good habit. And then you check out second table. And let's see, what is the y coordinate if x equals 6? It is 7. So the answer to this one is 7. What is the x coordinate if y equals 9? So then we just look to see if we can get lucky. Let's see if the y value is ever 9 here. This is going super slow. Okay, and it's if y equals 9. There it is. So when y equals 9, x equals 10. Okay, so see how you can answer these questions? You can answer these questions just by looking at the table. Just look at the table. If they give you y, you look on the right side. If they give you x, you look on the left side. And then you look on the other side to find the corresponding x or y. Easy, right? Okay.